want to get a good look at each of them. So that's why I've provided the colored pencils for you today. RMS, congruent to RNS. All right. I want a detailed look at both triangles. After we highlight them, go ahead, mark your diagram, and write in your givens. And I think a lot of you are going to be up for the challenge here of these challenging proofs. I think you're going to be up for it. You don't want to admit it, but you're hungry sometimes and want to figure out this puzzle that is a proof. All right, I just don't want to dive right in and start writing. Let's see what I gave you. Is it useful? TR congruent to TS. Are those sides in the triangles I'm trying to prove congruent? Look at the diagram. Is TR and TS sides in the triangles I'm trying to prove? No, they're not. Is everyone comfortable with that? Because I'm not putting an S next to it. That's why I ask you. Next given, TM congruent to TN. Are those sides in the triangles I'm trying to prove? No. So look here. I don't have an S or an A anywhere. So we are going to be responsible for all three pairs of congruent sides or angles right now. Givens are, even though I don't put an S or an A next to them, I still need to use them. Remember, I will never provide you a given that you're never going to use. They're always there to use. So how am I going to use these then? Where do we start? Matt, you saw something right away. What was it?
Subtraction.
Subtraction, yep. I'm going to subtract these two given sides to get MR and NS. Good call, good call. So I'm going to turn this proof over to you guys now. What's that subtraction statement going to look like in step 2? Here we go. 1, 2, 3, 4. Doyle.
TR
Yep.
minus TN equals TN minus TN.
Great job. Awesome. Subtraction. Good job. Next, what do I always have after a little subtraction or addition? But Matt, what else comes next?
Substitution.
Substitution to say what sides are now equal, Matt.
MR and NS.
Good. MR is congruent to NS. And now I can finally put a side there. I finally have a side. All right, 1 down, 2 pair to go. Where else am I going here now? Where else? And this is probably why I like you to highlight too. Z, what do you say?
Angle MRS.
Okay, you're going to go. Okay, all right, go ahead. Okay. Look, remember what I told you. Start using this isosceles triangle fact in your proofs. Notice triangle TRS. Everyone agrees that's isosceles, right? Because this is what I had. If I just draw a TRS by itself. That's what I had, right? That's isosceles. We learned yesterday what's across from the congruent sides, a pair of congruent angles. Take a look. That angle's in my yellow triangle. I don't know what color you have, but it's in my yellow one. And the other one opposite the other congruent side is in my green one. So I can count those as full angles. Yes. So angle, I'm not going to call it R though, because I don't know what you're talking about. If you say R, I'm going to name it with 3 letters, TRS or MRS. It's up to you. TRS congruent to TSR. We wrote this down a couple times yesterday. Got to start it off with the phrase in a triangle because it doesn't work for other figures. In a triangle, and now you guys finish it. You got to look back at your notes, look back, but in a triangle, 1 zip. Matt, on fire today. Doesn't matter. Doesn't matter. Remember, I don't care what comes next. Sure. Yep.
opposites are across from congruent angles.
There we go. I got it. Congruent sides are across from congruent angles. Or again, I told you guys yesterday, if you flip-flop the word sides and angles, it's fine. Okay, we got a pair of angles now. Got one more pair of something. Focus on the triangles, right? Focus on the, what else can you say here? Focus on the triangles. There's got to be something else here. We got to, see. Look at the triangles only. I need to find another pair of sides or angles. Gabby, what do you say?
RS.
And guys, that's why I love you guys highlighting. Because maybe you'll notice when you highlight, whoa! 2 colors are on one side there. 2 colors, one side. Reflexive, yep. And that gives me another pair of sides. And I think we have enough information. We found all 3 pair, right? Triangle RMS, congruent to triangle RNS. We do have 5 methods, but let's be honest, HL is not even an option here because it's not a right triangle. But what is going to be an option here based on what we have? What's my method now? Go ahead, Thomas.
SAS.
Side, angle, side. So the new thing today, we're still doing triangle proofs. Side, 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 angle, side, etc. The only thing is now to find that angle or side I still need, probably going to come from the isosceles triangle in every proof now. All right, so be aware of that. I'm going to skip over number 2. You're going to do that with your group in a second. I'm going to go to number 3, and that's the last one I'm going to do today because you guys need practice. Me up here yapping away isn't going to do you any good. So let's do one more together, and that's number 3. Ooh, look at this proof statement. Prove it is isosceles instead of being given it's isosceles. Prove to me that this is actually an isosceles triangle if we only know 3 and 4 are congruent. Show it's isosceles. But, okay, first question. What makes a triangle isosceles? What makes a triangle isosceles? Talk to me here. Aiden, what makes a triangle isosceles?
2 of their sides are congruent.
2 of their sides? Or I could have what else?
2 of their angles.
Either one, right? Either one would work. Would make it isosceles. So now I apply that to this diagram, and I say to myself, oh, if angles 1 and 2 are congruent, would we all agree it would be isosceles then? Or if AB was congruent to AC, it would be isosceles. Do I need both? No, just need one or the other. So which one can I do here? If I know 3 is congruent to 4, can I get 1 congruent to 2? Or can I get AB congruent to AC? I don't need to do both, just one or the other. I also wrote, 1, 2, 3, 4 for you to look at them. Notice I didn't put a number 5 here because I don't care about that angle. I only care about these 4. Is there a relationship here between any of them? A relationship between any of those angles we know about? Doyle, back to you.
Angle 3 supplementary to angle 1.
And, yeah.
And angle 4 supplementary to angle 2.
Great job. Everyone agrees with that statement? 1 and 3 are supplementary, 2 and 4 are supplementary. Where am I going with this? Well, that would mean then 1 and 2 are both supplementary to angles that are congruent, so 1 and 2 have to be. 1 and 2 are both supplementary to congruent angles, so they have to be congruent to each other, right? Okay, so 1 second. Before I say that, though, 1 and 2 are congruent, I need to tell you what Doyle just told us, which is 1 and 3 are supplementary. 2 and 4 are supplementary. And not because they form a straight line. We've used this reason over and over and over and over again to say angles are supplementary. You see? Linear pairs are supplementary. So we had two theorems. I know we just discussed which one it is, but just let's review again. We have two theorems. One says two angles are congruent if they're supplementary to the same angle. Are 1 and 2 supplementary to the same angle? Nope. We have the second one, which says two angles are congruent if they're supplementary to congruent angles. Are 3 and 4 congruent? There you go. So that's why 1 and 2 will be. 1 congruent to 2. Supplements of, not the same, but supplements of congruent angles are congruent. All right, 1 and 2 are equal. I don't need to go and say an extra step AB now congruent to DC. Is this triangle isosceles right now? If 1's congruent to 2? Yes, it is. So triangle ABC is isosceles. And I'll write a reason in here, but I want to know from somebody else. So how do we know this is isosceles now? How do we know this triangle is isosceles? In your own words. In your own words. I'll love to hear it. Matt!
Because two angles are congruent.
Two congruent angles implies I have a what?
Oh.
Or just
Isosceles.
isosceles triangle. Yep, that's it. If you happen to prove the sides instead, just substituted the word insides for angle. Two congruent angles. Okay, so that's how I'm going to show it's isosceles. I don't need both the sides and the angles. I just need one or the other. Okay, here's where we're going now. A lot of practice. All right, I want you to struggle. If you do struggle, I want you to struggle and call me over. All right, that's a good thing. All right, talk amongst your group because I don't want to come over and check it until your whole group is agreed upon. Go back to proof number 2. All right, highlight, do what you got to do. Call me over when you and your group are in agreement, or if you're just stuck, that's fine.